Chetan needs no introduction. Many of you know him. He is a general partner at Benchmark Capital. Benchmark Capital is one of the storied firms in Silicon Valley. And prior to this, he was a general partner at NEA. And he has had the pleasure and the privilege of working with some iconic companies, including Elastic, which is a 12 billion market cap, 13 billion market cap, thereabouts. MongoDB, $20 billion market cap. MuleSoft, that got sold to Salesforce for $6.5 billion. So Chetan has done really well. Every single conversation I've had with him, I've come out very inspired by his deep intellect, by his childlike curiosity, wonderful smile, and he's just an amazing human being. So welcome, Chetan.
Thank you.
And he's obviously has a great vantage point, and he has a great view in what's happening in the world of AI. So maybe for the audience's benefit, tell us a little bit about your backstory. Where did you grow up? Where were you born? How did you end up in Silicon Valley?
Yeah, I was born in Hyderabad. Moved here to the US when I was 7. And then I grew up in Washington, D.C. Then I came to Stanford for undergrad. And so that's how I ended up in Silicon Valley. And then so ever since I graduated, I've been here. And I started working in venture in 2011. But before that, I had a lot of time developing, did a lot of side projects and stuff like that. And so you can kind of tell the common thread in all of the things I've invested in. I really like technology that appeal to developers. I really like technology that makes developers more productive. And that's been a pretty common theme in my career.
Yeah, and did you invest in MongoDB when you were 25? How did you discover them? And
I was a user of MongoDB.
Oh.
And for me, as a solo developer, MongoDB was a huge unlock. Before MongoDB, a really big open source database project was obviously MySQL. And MySQL was a terrific project. It is extremely widely adopted. And the problem with developing a mobile application, a SQL database, is that if you don't know the end structure of your application, starting with a SQL database actually slows you down. You have to think about the schema, you have to think about how to implement it. And then, if you remember what the Apple ecosystem looked like, and many of you may not remember what it looked like in 2009, the primitives were very hard to deal with as a developer. And the things that Apple pushed you towards were things like running SQLite on device. Memory management was really tough. The ability to run an application in the cloud was kind of non-existent because EC2 and S3 were just very immature technologies, just being opened up. And so, you had to think about hosting your application on a server in your apartment, or once it got big enough, you would rent space and then host it. And so everything was just how fast could you get an application out? And my friends at Google and Facebook were so advantaged at the time because they had a really great custom stack that was available to them they could try new ideas on. And so the amount of advantage they had if they had an idea, and the amount of time somebody at Google would take to go from idea to prototype was a very short amount of time. And they had their own versions of NoSQL databases. And then you started to see around 2009 and 10 open source projects really coming up. And it was huge productivity tools for developers because, especially for me, MongoDB, you could just pick it up, not worry about schema, not really worry about all these things that you used to think about from a database perspective, and really worry about the idea itself. Try to get a prototype out, try to get a production application. And of course, at that time, it was not a particularly stable database. It got annoying at scale and all that stuff. But those were considered sort of fancy problems. It was you wanted to get to the fancy problems and worry about it at that time. And then the thought you always had was well, how hard could it be to replace a database anyway? And so I just saw at the time that I was using MongoDB, all the developers I respected were using MongoDB, all of the sort of fast-growing mobile apps were usually built on MongoDB. So at the time, Foursquare was a very hot social app.
Yeah.
That was built on MongoDB. And so you just saw like there was a lot of developer activity. And so I just got to know the team, got to know the founders. And from a business perspective, it was a very like immature and small business. But to me, it had a lot of potential because it had grabbed a ton of developer mindshare. And monetization, the theory of monetization also to me was like pretty obvious because I knew that the database was, basically telling you to not worry about the fancy problems until you got to like scale, where you cared about replication and durability and all that kind of stuff. That it just sort of encouraged you to forget about all the problems. And I knew that once you got to those problems, like it was actually problematic, and you would pay a lot of money for somebody else to solve those problems. And that's where the business theory was also very obvious to me, is that that's where like MongoDB could easily step in as a company and offer either proprietary software or services or something like that to essentially help monetize the business. And so, to me it was like not a particularly, it felt very obvious to me at the time. And I think it was partly because one, I was naive about how hard it was to build a business. And two, I was just such a user of the underlying technology itself that I just understood the differentiation at a core and intimate level that, I think that gave me a true sort of unique viewpoint on it.
You were early in like three really interesting, iconic companies between MuleSoft and Mongo and Elastic. Like, were there some commonalities between these three companies in early days that compelled you to like them and make an investment?
Yeah, I think the common thread in all of them is that they enable dramatic developer productivity. Interestingly, all three had very different origin stories and very different sort of like progression. MongoDB was founded in 2007, and so the company, by the time I had invested, was already 5 years old. I invested in MuleSoft in 2013, and that company also started in 2007. Well, MuleSoft was very interesting. It started as an open source project and basically had, really struggled to monetize. Greg Schott joined as CEO and essentially took over the company, and then had to downsize the company pretty dramatically, and then had to like rethink the product strategy, monetization, and then sort of slowly build it up. And by the time I had invested in 2013, like they had gotten to not quite $20 million run rate, but like call it, let's say $15 million run rate, but it had taken a long time to get to $15 million run rate. Like they started in 2007 and it's summer 2013, and they're at like, call it $15 million run rate. Like that.
Through shading, 6 years.
Yeah.
And we have cursor 0 to 118 months.
That's right. So it's like it was a long, grindy process doing, essentially middleware. But what was remarkable about MuleSoft is, in 2013, it was sub 20 million ARR. By 2018, it got to 325 million of ARR and got acquired for $6.5 billion.
Wow.
So if you just think about it, like it took them forever to get to 15, but it only took 5 years to go from 15 to 325 million. And there's lessons in that. Like there's like lots of lessons of persistence, like have you built a really valuable product? I would say as they scaled, they were perhaps the most efficient scaling company I've ever been part of, and might be the most efficient scaling company I'll ever be part of. Like, they were unbelievably efficient for what they did, which was pure enterprise sales. It was a heavy piece of software that needed implementation, that needed professional service, and all of that still didn't have them burn very much capital. Like, from 100 million to 300 million, I think they cumulatively burned like less than $10 million. Maybe they burned $8 million or something like
Let's
that.
double click into that. Why do you think it was so slow before it was sudden? And why was this company so capital efficient?
So I think
people burn like $30 million in like a couple of quarters these days.
Yes,
like,
that's right. I just think that like for MuleSoft itself, they had a very tough time raising capital, always. And they were just forced as a company and as a team to be capital efficient from early days. Like every marginal dollar mattered because like it was unclear that they were going to be able to raise the next round. Number two, because they had deep constraints, they were forced to be very innovative on how like they could achieve efficiencies. And then two, they were very, very, very prescriptive about product market fit. And you know, they were an open source product, but they had this mental model that, okay, there's open source MuleSoft, and there had to be a pretty wide gap. And then on the other side of the canyon was like proprietary MuleSoft. And all the money was going to be from the proprietary MuleSoft that was going to layer on top of the open source. But this, like, they had to spend a lot of time getting open source MuleSoft. Then they had to build a lot of proprietary code that they could then go sell on top of the open source community. And look, it just took them a long time to build the open source community. And then they started to build the proprietary code. And then that took a really long time for that to get mature. And so by the time, like, yeah, it just took a really long time to build all aspects of this. And yeah, it took 6 years to get to 15 million revenue. And, you know, I just think that that just is a continuous lesson of like, every company has its own journey. And just because like it has a certain growth rate to a certain point doesn't mean that there isn't a massive inflection that isn't about to show up. And it could always show up. And they were also propelled by a macro trend in cloud. So MuleSoft as an integration platform became very powerful for an enterprise. Like if you just had Salesforce, it was useful but not that interesting. If you had Salesforce and ServiceNow, it was interesting. If you had Salesforce, ServiceNow, and Workday, once you got to the third SaaS app, it became essential.
Interesting.
And then by the time like 2013 rolled to 2014, enterprises not only went from like one SaaS app to 3, they went to like 15. Then the next year they went to like 30. And so like you had a huge macro tailwind finally show up. And you know, these guys were building SaaS integration starting in 2007. And it was like
it's too early.
Too early. Like the only SaaS company that people had was like Salesforce. And you know, you could like, and Salesforce had its own integration tools and had its own platform. So like you don't really need them. They just made things easier. But once SaaS really took off, they were dominant. And they clearly rode that wave really, really well. And what ended up happening, and it was fortunate for them, is that they got to experience the huge tailwind after they had built a very mature product. And so what ended up happening is as the tailwind showed up and you had a whole bunch of startups show up to compete with them, they really couldn't compete with them. They had a massive community, massive open source community. They had more connectors than anybody else. And they had all this proprietary software that they had been building for so long that like when the moment showed up, they were just like perfectly positioned. And they just ran. And so, you know, it was like market timing plus having to train yourself to be like capital efficient really enabled them to ride that wave really, really well. It was a remarkable company.
You know, building on that thread of going slow to go fast. Of course, MuleSoft took all that time, and finally it made it. And I think now it's crossed maybe a couple of billion of ARR. I always thought that the conventional wisdom in Silicon Valley was blitz scaling.
Post acquisition, it went from 300 million to over $1 billion in 18 months.
Wow, so it kept accelerating.
Yeah.
It's certainly growing very fast at scale.
Yeah.
But I thought, in Silicon Valley, the conventional wisdom was to blitz scale, and so many books have been written about scaling and going fast and breaking things. So how do you reconcile these two philosophies of company building?
Look, sometimes things do go fast, and that's awesome. Like it'd be great if everything just went really fast. As an impatient person, that would be great. But the fundamental reality is that software is a really interesting market, and like part of the advantage you get by being sort of like gradual about this is one, you get to build in silence. Like if the market's really not happening and not a lot of people are focused on you and you're not a hot company, it's like a blessing in that nobody else is trying to build what you're building. So you just get to build in silence. You get to build this like massive tool set You get to build this like really mature software, and nobody's kind of like paying attention. Nobody's trying to recruit your people. Like everybody's like you're like in the shadows, and like you're just left alone. And you just get to grind and grind and grind and get to a point of maturity. And then eventually you get to show up and take the market. And by the time you're taking the market, like you've just caught everybody off guard because like you've just been building in the shadows for 7 years. And like now it's like go time and you're just ready to capture the market. On the other hand, like sometimes you build a software product and the moment is happening now. And yeah, you can go build in the shadows, but it doesn't matter because the market is about to just pass by. And if you're not on this train right now, like it actually doesn't matter if you're great in 5 years. Like who cares? The market's happening right now. To jump on this train, you gotta go. The problem with that is like those industries means that it becomes hugely attractive for capital. So it's very unlikely that if you see a company going very fast that they won't have like 10 well-funded competitors. It's also very unlikely that the incumbents are sleeping on that market opportunity. Yeah. So the incumbents themselves will be releasing products. And the biggest thing incumbents like to compete on is price. And so immediately the price elasticity of your demand curve disappears. And it's just this fight. It's just this fight. And you know, like the great example I have of this is Elastic and Elasticsearch, which of course, like, unlike MuleSoft, which took a long time, Shai created Elasticsearch as an open source project. He created it as a personal project. It took off. It became an unbelievably popular open source project. He formed the company around Elasticsearch in 2012. Series A was 2012, Series B was 2013, Series C was 2014, and IPO was October 2018. So it just went, and the scale was amazing. Like I think it went 0, 7, 21, 60, 120, and it's like, you know, $1.5 billion now. So it's like, it just went very fast. Now, this open source movement was growing really fast. The business was doing really well. And of course, it attracted a ton of competition. There were lots of people that took that open source project and tried to compete with Elastic in multiple ways. And so, yeah, when you have something that's going very fast, that's growing very quickly, it attracts a lot of attention, it attracts a lot of capital, it attracts the incumbents, it attracts startups. And that's, you know, it's an incredible journey to be a part of. It's very exciting, but it's also incredibly stressful. And like, you know, there's like multiple ways to build a company. And I think there's some people and some companies in some situations that are blessed with that spotlight. But that's not the only way to build a great big company.
So let's say you're one of the founders here. You are in a very hot category. You've got lightning in a bottle and things are going very fast. And you're one of the early, you know, front runners of winning that category. And you try and scale the business. What can go wrong? What are things that you've seen usually go wrong when you try and scale the company at Elastic and some of the other stories that you've seen?
Well, there's two main things that happen. One, if you don't build, especially in software, if you're not building great, valuable software, what you'll see very quickly is churn becomes your biggest problem. So the battle essentially becomes like every day you're spending all this energy and capital to acquire customers, and basically the water comes into the bucket and it's like falling out every month. And it's just like, the thing about churn is that the like longer you deal with it, wait to deal with it, the harder it is to deal with it. So dealing with churn when you have 10 customers, pretty easy. It's like, okay, like 3 are gonna churn. I don't want these 3 people to churn, so I'm just gonna like dedicate my entire product team to like save this churn. Like that's possible. Yeah. 10,000 customers and 30% churn, like not gonna happen. You can't save it. Like, and then it just becomes this data problem. It becomes like a product problem. Is it a, you know, do I have the right product people? Do I have the right engineers? Do I have the right roadmap? Like all this kind of stuff becomes these like mental traps. It's like a horrible set of decisions you have to constantly make. And then once in a while, you'll just be like, forget it. Like we'll just grow out of it. And then you just like ignore it. hoping it goes away, and then like you keep scaling and the churn gets worse. And the really unfortunate part is if the market is moving really fast, you might not have the time to deal with that. And that's like a thing that just like completely crushes companies. And it's a very tough problem because like it's one that requires being thoughtful. And you're like, well, the market's moving. I can't be thoughtful. So like scale really matters, and I need to get to scale. And so it's like these countervailing pressures. And those situations are really, really tough. And they require deep thought, fast execution, and quite a bit of luck, I think, frankly. And then the second one that makes things fall apart is just that as you grow the team, there is a natural, sustainable rate at which teams can grow. Cloudflare had a very methodical way of growing the team, I thought. Like that was another one where they had a lot of adoption, but not a lot of revenue for a while, and then revenue like really grew really, really fast. But just remember that they had a very strong philosophy about the team could only grow at a certain rate. Like, if you grew the team 2x in a year, that meant half your company was new.
Yeah, scary.
And so like if your company is half new, have you onboarded them effectively? Do they really understand the values of the company? Do they really understand what the company is here to accomplish? Do they know how to actually talk to customers? Do they actually know like what kind of values we espouse to in the product? Do they really understand like here are the things that really matter? Here are the things that people really care about when they use our product? And let's say the team grows by 3x. And of course, that means that 2/3 of the people are new. And then the chance for miscommunication, lost in translations, things to drop through cracks explode. And along the same lines, you end up hiring, people with lots of experience and fancy backgrounds. And, the implicit expectation as a founder is that you should be able to just turn over a function to them and hand it over, and they should be able to run it. But the problem with that is that person is new to this company. They became experts at their previous company and became very accomplished. But they have to learn this new company. There's an onboarding period, and if there isn't sufficient onboarding or the onboarding isn't successful, then you're scaling sort of blind. And that can be really tough.
We see plenty of companies get to 10, 20, 30, 40 million ARR quickly and then compound. But what I find truly remarkable is companies, that grow fast even at $1 billion scale. And Elastic is a good example. Datadog is a good example. Cloudflare is a great example. Yeah. What do you think? What have you seen these companies get right? Because they're to be able to grow meaningfully at scale. Because they're only, unlike consumer businesses in B2B, there are only so many customers that you have, right? The world only has so many enterprises. Yeah. And beyond a point, you run out of enterprises. So how do you continue to compound at scale?
Well, I think the common theme has always been at some point you absolutely do have this maximum set of customers. And so is it 10,000? Well, for some it's like 5,000. For some it's 10,000. For some it might be 50,000, whatever. I guess like the maximum TAM size of any B2B business, you just have to look at a hyperscaler and be like, okay, that's kind of like the upper limit of the number of customers. And it might be just a lot smaller depending on what price you want to set. Ultimately, like, what product surface area are you going to be able to cover? And how many adjacent products are you going to be able to successfully execute? It's been the unlock for all of these. And I think like there's been like sort of the main product, then there's been the second product. And then for the ones that have been able to grow at $1 billion, it's like not only was it a first and second product, there have been multiple acts that have come through, either a lot of organic innovation, but successful acquisitions, successful tuck-ins, whatever it is. But like, it's always been this idea of like, there's this main product, then there's a second product, there's a third product. And if you just look at Cloudflare, for example, like huge suite of products. If you look at Elastic, for example, lots of products that you can consume. Same thing with MongoDB. Like they have, just in terms of like, it is a database product, but you can consume it in so many different SKUs now. And the number of features they have across the database, depending on what kind of customer, what you're trying to use it for, really remarkable. And so, yeah, I think that's it. It's about the main product and the adjacencies that you can keep innovating on. That requires a really strong product engineering culture to keep innovating. And naturally, the organization is going to feel a lot of gravity towards the established projects and products because those are easy to sell and easy to monetize. And those tend to gain a lot of status within the organization as that's the place where I want to work. Those are the products I want to work on. And so it requires a lot of creativity from the company's management team to encourage new products to come, to encourage a culture of experimentation. Because as you try new products, it's guaranteed that like those new products are not always going to work.
Yeah, some will fail inevitably.
Yes. And what happens when a product fails? Like, how is failure processed in an organization? And so those are all like really hard things to manage through. And then some people are just really good at it. Even first-time founders.
We got to chat about AI.
Yeah, of
last
course.
time I was here, we had a long conversation about all the hyperscalers and frontier labs plowing in billions of dollars. And I must say you were prescient in saying that, startups will have a play thanks to open source. And with DeepSeek, your prediction has come true. So tell us, and of course, one of the seminal moments in the evolution of AI, and NVIDIA lost whatever 500 billion of market cap that day, so it was a very important day. Tell us what DeepSeek has done to the world of AI and what opportunities and risks has it created for startups? Like, how does it impact the life of startups trying to build on top of foundational models?
I mean, it's for an early stage investor, it was just a remarkable moment. Like V3, which came out in December, was amazing. And then you saw R1, which came out in January. It's such a huge unlock. There's two things that happened. So we had open source models before DeepSeek, but we never had somebody put out a combination of code, weights, and research and license it under a permissive license like MIT. So if you looked at every single open source model before DeepSeek put out these models, anybody that was like close to frontier had a weird license attached to it. So if you looked at like what Meta had launched, which were great models, by the way, but then an interesting license, which was like, you do whatever you want with these models, except if you had this many users. Then you had to come get a special license from Meta. And it was fine, and people managed through it, but I think it slowed the ecosystem down. What you saw with DeepSeek was it was a frontier-level model that was released fully open source and just put out there with all the research and all the code and all the weights. And it was packaged so well such that you could like download it and run the giant model locally. Like it was a 400 gigabyte model. Like it was not hard to run. So they put out R1, and you could immediately take it yourself and either, you could use Olama and run it on your desktop, you could, or a local machine, you could take Fireworks and host it on Fireworks. And the other thing that happened was because of the MIT license, you were able to run DeepSeek on AWS, Azure, and Google within a matter of days. Like they stood them up very quickly. And you could run open source packages on top of these models to sort of like take out whatever you didn't want out of them. And then you just had your own DeepSeek. And if you just looked at the pricing that all these vendors offered, like it was unbelievably low cost. So up to that point, O1 inference, output inference was $60 per million tokens. As soon as R1 came out, if you wanted to run R1 locally yourself, the equivalent cost was something like $2 or $3 per million tokens if you were like skilled enough to run it yourself. If you wanted an inference hosting provider to run it for you, it was $8 per million tokens. I mean, and then now that cost has even come down even more. I mean, I downloaded it and I started running it, and I was like, and I just started hitting it with unbelievable amounts of requests. It was it was like high performance, and I loaded it up like $50 of AWS credits. And it took me a long time to burn through $50. Like,
what were you building?
No, I was trying to code with it. Yeah, and then I was also sending, like, the natural language requests were not actually consuming very many tokens, which was very surprising. The code was like consuming tokens, but like, it was just a remarkable experience, and very clearly, I think the ecosystem here very much recognized immediately it was one of the most seminal moments in AI. Like, it was equivalent to the ChatGPT moment.
Yeah.
Because it just opened the eyes of like every developer here of what was possible. You had now a fully capable model that's completely open source and available to you that you could just take, run, fine-tune, train, customize, distill, whatever, right there. And I think immediately you just started to think about, from a startup perspective, if the model layer is essentially free, now what can I do?
Yeah.
And the thought process you had as an AI application developer was two things. One, like, you had to build your AI application. Two, as you were powering inference on your AI application, like, making sure that inference actually stood up to the load that you were about to handle was a very difficult problem. So whether you hit the APIs at Anthropic directly, whether you hit the Anthropic APIs via Bedrock at AWS, you hit OpenAI directly or OpenAI via Azure, or you did your own open source model, which had its own issues, like, you had to think about infrastructure in a way people hadn't thought about since 2010 and 2011 and 2012. Like, the deal with cloud in pre-AI was like, I put this up, I put it on AWS, I load up a bunch of money, and it just goes.
Yeah.
Like, and the SLA is 99.99999. It's 24/7. I don't have to worry about the infrastructure.
Yeah.
But all of a sudden, all the AI app people had to become infrastructure experts. And then network latency mattered, like where these models were hosted, where you were getting inference all of a sudden mattered, because if you had users in Europe, their data couldn't be stored elsewhere. It's like, it became a huge, complicated effort. And all of a sudden, you had a model that you could run literally on VMs everywhere. And it was cheap. And so, AWS, I think just like a week after the model was released, basically said if you use DeepSeek on AWS, you can just pay for the bare metal rate. And we'll just charge you per hour. And I think, like, if you just calculated the million token cost of that, I think they were charging like a couple bucks. And so all of a sudden, like, that equation changed. It just like flipped immediately. And of course, like, DeepSeek comes out, and then of course OpenAI, which is an unbelievable organization, puts out O3 Mini, and then the price of O3 Mini is $4 for a million tokens. Again, like, competition is unbelievable at the application.
Like, great for startups, right?
That's right.
Great for
Immense competition at the model layer is great at the application developer layer, because, like, if you have more choice, if you have more models, as a developer, you can now do just way more things. And you just don't have to think about the immense expense that it's required, the huge network engineer, all this kind of stuff. Like, you can just do more with less, which is huge, which means that I suspect that the application layer, actually every layer of that stack, you're going to see just a lot more startups doing a lot more interesting things.
What are some of the second, third order impact of the model layer getting commoditized or democratized? Do you see some parts of application economy coming to life because now the models are very cheap, and that will, that's a huge shot in the arm for the application economy? What are some of the second, third order effects of DeepSeek and this model commoditization that's underway?
Well, one, I think that if you just look at infrastructure build out, and if you just look at hyperscaler CapEx, it's a very easy trend to see. So if you saw ChatGPT, and if you summed up the three large clouds in America, Google, Microsoft, and Amazon, and their CapEx builds since ChatGPT, what you'll see is year-over-year growth of CapEx like exploded. And then if you look at what everybody's guiding to now, you basically saw, and CapEx growth had actually turned negative pre-ChatGPT, so people were actually spending less because it was like, we could just get more efficient and it was fine. ChatGPT shows up, then essentially everybody's CapEx explodes. And then now what everybody's guiding to is like, mid-teens % year-over-year growth on CapEx. And I think what that signals to everybody, and they were signaling that even before DeepSeek showed up, I think what that signals is there's been massive CapEx build out of data centers over the last 3 years, call it, 2.5 years. Now, all of that CapEx has gone into these chips and this infrastructure that's all coming online. All these models are coming online. You're gonna, DeepSeek isn't gonna stop. There's gonna be more models. R1 is out there, V3 is out there. There are a lot of developers working on those models and building on top of those models, so you'll see tons of new open source models come out. All that means is that you're now getting these ingredients finally in place where if you're a developer and you want to build a consumer app for scale, you now have the components where you can actually afford to go serve 1 million or 10 million users efficiently. Now that isn't actually possible if the cost of inference is $60 per 1 million tokens. You really can't have a massive expansive free tier and then worry about monetization later. So part of what Facebook got to benefit from is they just had a non-monetizing application that got to build a giant network effect before the ads turned on. Well, it's actually really hard to build a network effect with AI if the cost of consuming the AI is really high. Your unit economics can't pencil out. And you know what the worldwide expected monetization for consumer users are. It's it's one thing for the US, but in India and Southeast Asia, it's very different. And so if you're building a global consumer app, the cost of AI is actually a prohibitive expense to build consumer experiences. And I think that's part of the reason why we've seen so much innovation in enterprise, because in enterprise, you can attack very high value problems. And even if the cost of inference is expensive, you're able to monetize that. I suspect that with all these innovations, you're going to now start to see really interesting consumer applications. And I'm really excited about that. And I think that a lot of the analogies of what's happening in AI, if you just study the telecom build out, everything has a lot of rhyming analogies here.
True.
And the network has to get built out. The layers on top of the network have to get stable. Then and only then can you build really interesting consumer applications.
True. On that note, Chetan, thank you. It was
Thank
a pleasure,
you.
and thanks for sharing your journey and insights. Thank you.
Thank you.